what happens when you execute a time-consuming function when a button is clicked? Well, you will see one of these. The problem is that currently my file manager uses threads for I/O stuff. The idea of cooperative multitasking is that tasks are chopped into little pieces and executed serially. I click the screen. Much better. What is the difference between a library and a framework? A library provides functions that are called by your code, and frameworks call your code. Examples of frameworks are web frameworks like Django. Django processes web requests and allow you to hook in your code for specific events. Another example are GUI frameworks. A GUI framework has an event loop that constantly checks OS events like mouse and keyboard events. So, what happens when you execute a time-consuming function when a button is clicked? Well, you will see one of these. Or worse, you have to kill an app by force quitting it. In this video you learn how to solve this problem with Python's async await mechanism. On every platform or with any language that I learn, I create a file manager like the Norton commander. I do this because it requires me to implement many of the things I want to learn on the platform. I created one for Windows Surface and one for macOS. For macOS I use Qt and Python. The problem is that currently my file manager uses threads for I/O stuff. And although it works, I want to steer away from it and use cooperative multitasking with Python's async I/O module. With threads, tasks are executed parallel. The idea of cooperative multitasking is that tasks are chopped into little pieces and executed serially. This way, the program never has to switch contexts and there is no danger that finished threads change state in unexpected ways. Now, most demos on cooperative multitasking show code that retrieves data from the internet. For example, it shows how 5 web requests can be executed, and since the bottleneck of these operations is the waiting for the response, they are executed simultaneously with Python's async I/O module. But I need more. My problem is that I want to integrate asynchronous code in an already existing GUI event loop. What you will see here is an experiment to call a blocking function from Pyglet and make it behave asynchronously. Look at this code. Class canvas inherits from a Pyglet window and the class initializer creates a progress bar rectangle. I create a custom game loop. The progress bar will be drawn roughly 60 times per second. I create a canvas instance and call start. And that works. I will now create a blocking function that needs to report its progress. The goal is to update the progress bar while the function is doing its work. I add a function that takes the progress bar. With a loop that updates the progress bar 400 times. This function calls time.sleep with a 10 milliseconds delay. The function will block everything else 4 seconds long. I call it when I click the screen. When I click the screen, the app will freeze 4 seconds. Let me show you. Nothing happened for 4 seconds and the OS even showed that the app was non-responsive. Instead of a nice moving progress bar, the app froze, and when the function was done, the progress bar jumped to 100%. I need a better strategy, and for this I will use asyncio. The first thing I will do is make the start function awaitable. Does this make the start function awaitable? Not yet. Awaitable functions need to yield the control to the event loop at regular intervals. I do this with the sleep function. I import asyncio. At this point, the start function is properly awaitable and can be called from other async functions. There is only one problem. Start is called from the main script, which is synchronous code. So, to await a function from synchronous code, I can use the asyncio run method. And that should do the trick. I'll try it. I click the screen. I wait. Same behavior. At this point, start is awaitable and it yields control to the event loop. Start is called asynchronously, but the process function is still blocking. It also needs to be awaitable and yield control. I make the process function awaitable and yield every iteration. And now I have to schedule the function call to the event loop. For this, I use the createTask function. And that should work. I click the screen. Much better. There is now an infinite event loop and asynchronous functions can be scheduled on it with the createTask method. I'm pretty sure there is more than one way to achieve the result I want, and I will do more research. The next thing I want to achieve is to integrate an awaitable function in an existing queued event loop. And when I'm done, I will link to the video here. Stay tuned.